Okay, to solve this question, we can use the mnemonic. Romeo's mother is very ugly, exclaim grandma. Okay, so R will be radio, M is microwaves, infrared, visible light, ultraviolet, X-ray, and gamma ray. Okay, so we have to actually list them in terms of in order of wavelength and frequency to help us. Okay, so we start with two column of wavelength and frequency. So we just need to memorize that the gamma ray, right, is the most dangerous, so it has the highest frequency. That means the radio wave will be the opposite, so it has the lowest frequency, and the frequency increases down the row. Okay, then for wavelength, right, gamma ray has the highest frequency, it must have the lowest wavelength. Okay, then radio wave will have the highest wavelength, so it goes in the opposite direction. And now we want the longest wavelength, so that will be radio waves. Okay, answer C. We have a pair of charged spheres, so we are supposed to indicate the directions of the electrostatic forces. So you just need to bear in mind that unlike charges, they will attract, and like charges, they will repel. Okay, now let's look through the options. These are negative, negative. Like charges, they should repel and not attract. Okay, this is option B. Positive and positive, they should repel. So we should either see a repulsion or a attraction. There is no way we will see a charge moving up and the other charge moving downwards. Okay. These are unlike charges, positive, negative, they should attract instead of repel. Okay, that left us with answer D. Okay, this is positive, negative, unlike charges, they attract. Given the first diagram, we have the current as well as the resistance. Okay, we can find out what is the voltage of the battery. Okay, so we can use the formula V is equal to IR. That will be 3 times 2, 6 volt. Okay, so this is 6 volt. And as we look at the second diagram, we can deduce that the battery is the same, so it is 6 volt. And now the change is in the wire. This resistance wire is 1 meter and it is 2 ohm. And we increase the length of the resistance wire by 2 times. And since the resistance wire is directly proportional, the resistance of the wire is directly proportional to the length. Okay, so if the length is twice, the resistance must be twice as well. So the resistance, it will be 2 times 2 is equal to 4 ohms. And given the voltage and the resistance in this series circuit, we can find out what is the current. Current is equal to V over R. That will be 6 divided by 4. We get 1.5 ampere. Okay, now let's look at the option. The resistance should be 4 ohm and the current should be 1.5. Answer C. Okay, in order to check the brightness of lamp Y, we have to look at the current. Okay, because the current determines the brightness. The higher the current, the brighter the lamp. Okay, and the current is dependent on the resistance because it's equal to V over R. So when Z is being connected in parallel with Y, it changes the resistance of the entire circuit. Okay, so in this case, let us check what is the change. Okay, let us give each lamp an arbitrary resistance. Let's say it's 2 ohm. 2 ohm. Okay, initially, right, just looking at the original circuit, is a series circuit with 2 resistance in series. So the original is 4 ohm. 2 plus 2. Okay, now when we attach lamp Z in parallel with X, right? Okay, this branch resistance can be calculated as 1 over R is equal to 1 over 2 plus 1 over 2. So 1 over R is equal to 1. This resistance is equal to 1 ohm. So this combined parallel branch, it actually decreases from 2 ohm to 1 ohm. And the total resistance, we plus this together, this is 1 ohm, this is 2 ohm, we'll get 3 ohm. Okay, before this circuit, we have 4 ohm, and after we attach lamp Z, we have this circuit which gives us a total of 3 ohms. We can see that the resistance decreases. Okay, so if the resistance decreases, the current that is flowing through lamp Y, it will increase. So if the current increases, lamp Y will get brighter. Okay, so the answer should be A, brighter than normal. Okay, we know that the battery is 6 volt. Okay, since the battery is connected in parallel to the 2 ohm and the 4 ohm, the potential difference across the 2 resistors, it should be 6 volt as well. Okay, so we want to find out what is A2 and A3. Okay, we can just use the formula. Okay, I2 can be just equal to the voltage divided by the resistance. That will give us 6 divided by resistance 2. That will give us 3 ampere. Okay, then I3 can do the same thing. I3 is equal to 6 divided by 4. That will be 1.5 ampere. Okay, so in this case, we have I2 as 3 ampere, I3 as 1.5 ampere. Okay, so now if they combine together to form the current 1 that is recorded by ammeter 1, it should be 3 ampere plus 1.5 ampere. The current flowing through A1 should be 4.5 ampere. Okay, so now let's look at the option. A1 4.5, A2 should be 3, and A3 should be 1.5. So the answer is D.